All right, so we're moving on to a new topic in our class. You're going to find at this part of our class, we just kind of bang, bang, bang through lots of topics because it keeps looping back to things that we've studied before. The unit that we just finished was on solving systems of equations, but the majority of that unit looped back to things that we had learned previously about lines and linear functions and how to graph and how to manipulate, solve linear equations, all those sorts of things. This little mini unit is the same thing. We're going to talk about quadratic functions in this unit, and you're going to see that almost everything we're going to talk about in this unit will loop back to when we talked about quadratic equations and quadratic expressions and things like that early in our class. Okay, so we're going to have this little unit this next week or so. The primary focus as we study quadratic functions is going to be on graphing. In fact, of the 4 days worth of notes that we'll take this week, 3 out of those 4 will be about graphing. Okay, so we're going to take the concept of graphing and break it down into 3 parts. And then the last day we'll be talking about applications of quadratic functions. So that's kind of where we are in our class. And that's kind of the way the next couple of units will flow, is we'll have these short little mini units that remind us of things that we've learned before, but apply those things in a new way as we talk about functions in particular. All right, so with that said, let's take a look at our learning objectives and get started with this video. 3 learning objectives in this video. The first one is review. Recognize a quadratic function when you see it. Make sure you can put it in standard form. Remember, part of standard form is identifying the values of the standard variables A, B, and C. All of that is review. We did lots of that earlier in our class, but we'll talk about that again real quick today. Know the basic parts of a parabola. So you might remember that the shape of a quadratic function's graph is a parabola. Just like the shape of a linear function's graph is a line, quadratic functions, their graphs are always shaped like parabolas. So we're going to talk about the basic parts of the graph. And then the main thing with our video, like I said, we're going to take this idea of graphing and we're going to break it down into 3 parts. The first part will be finding these 3 things in the graph. In the next video, we'll talk about finding some of the other parts of the graph. And then in the third video, we'll put it all together to make the full parabolas graph. Okay, so with that said, let's get started. And we're going to kind of get started in reverse order. We're going to start by talking about the basics part of a parabola and making sure that we can find these 3 things on the graph. So here I have just a random parabola. This is not any particular parabola, certainly not a parabola whose equation you need to know or anything like that. There's my x-axis, there's my y-axis, and there's my parabola. Okay, so as far as our class is concerned, there's a few basic parts of the parabola that you need to know. And one of them is probably something that you've learned before, the very bottom of the parabola. Or if the parabola happened to be shaped this way, then it would be the very top, right? We could have both. Since we're studying functions, we will never have a parabola that goes this way because that fails the vertical line test. That's not a function, right? So here we have a parabola. It's opening up. And so therefore it has a bottom of the parabola, okay? That bottom is called the vertex. And that's one of the things we're going to talk in this video about how you find the vertex, okay? The vertex will always be either the very bottom of a parabola if it's opening up or the very top of a parabola if it's opening down. But that's the spot that we're going to find, one of the spots we're going to find in this particular video. Okay. Another thing we're going to find is notice that this parabola has symmetry. If you remember, symmetry means that one part of the graph is the same as the other half. So if you think about this half of the parabola here, that half of the parabola is identical. They're mirror images of each other. So there's right-left symmetry associated with this parabola, which means going smack down the middle of the parabola is a vertical line that is what you would have called back in geometry class the axis of symmetry. Okay, the axis of symmetry. So if you remember back in geometry class, or maybe you've studied it in some of your science classes or things like that, the axis of symmetry in this case acts kind of like a mirror. And so what's on one side is the exact mirror image of what's on the other side, okay? And that's the kind of thing that we're talking about. If I were to take my graph and fold it in half right along the axis of symmetry, you can't see it because it's on paper, but the 2 halves of my parabola would exactly line up and exactly match and exactly touch everywhere, okay? So that's a second thing that we're gonna find in our video today, okay, in this video. One thing to notice, it's not an accident. The line of symmetry will pass right through the vertex, right? If the vertex is the very lowest or the very highest spot, then the line of symmetry has to go through that. If the line of symmetry were going someplace else, then you'd end up with this wonky sort of thing that doesn't match anymore. Okay, so the line of symmetry will always go through the vertex. So in a very real sense, you'll see in this video, if you can find one of them, you found the other one. Okay, they go together. They really go together. Okay, now the last thing we're going to talk about in this video is the idea of concavity. Concavity. Okay, now you don't need to know a formal definition of concavity or anything like that for our class, but you do have to have a working understanding of what it means. So in maybe some of your science class, you might have studied lenses or mirrors or things like that. In geometry class, when you studied polygons, you might have talked about things that were concave versus convex. All right, well, when we talk about graphs in algebra class, technically this is analytic geometry, but when we talk about graphs, we always call something as concave. We never talk about something as being convex. We always consider it to be concave. And then what we do is we talk about what direction is the cave facing, okay? So this particular parabola right here is called concave up. Concave up is what we call that, okay? And the way that I remember it is that concave up is like a cup. Concave up is like a cup. And you can kind of think of this, if we put, you know, a long little flute down on the bottom here, it's kind of like a champagne glass, right? That's kind of the shape of this, is kind of the shape of a champagne glass. So you could see somebody pouring water or milk or juice or champagne or something into this and filling it up. And that's the shape of something that's concave up, okay? Of course, you could also have a parabola that goes the other way. So just very quickly, if this is my graph and this is my parabola, now my vertex is at the top. I still have this axis of symmetry, but my parabola, if I was to pour something into it, it would just run off, right? It wouldn't go in, it wouldn't fill it. So this is a different kind of concavity. This is called concave down. And the way that I remember it is that concave down is shaped like a frown. Concave down like a frown, right? If this is, you know, this is somebody who's sad because they just spilled their drink, right? There's their frown, right? They're sad, very sad little person. Okay, so there's the concave down, it's like a frown. Concave up, shaped like a cup. You can fill it, pour stuff in it, it won't spill out. Concave down, it's like a frown. You can't pour anything on it, it just runs down. It doesn't hold anything. That's concave down. Okay, so in this particular video, oh wait, I almost forgot. For this particular video, those are the three things we're going to find. We're going to find concavity. Is it concave up or is it concave down? Where's the vertex? Where's the line of symmetry? There are two other parts of the parabola, though, that you will need to be able to find. And in the next video, we'll talk about how to find them. The first is the spot where the graph crosses the x-axis. So you'll see that frequently, not always, but frequently a parabola will have two spots where it crosses the x-axis. Those are called x-intercepts. And there's the spot where the graph crosses the y-axis. The parabola will always cross the y-axis. That is called the y-intercept. So in the next video, we'll talk about how you find intercepts. In this video, we're going to talk about the vertex, the axis symmetry, and is it concave up or concave down. In the next video, we'll talk about how do you find the intercepts. And then in the third video, we'll put all that together to start making graphs. Okay, so here we go. How do you decide, first of all, concavity? It is the easiest one to tell. It is the easiest one to tell, so that's what we're going to start with. How do you tell if something is concave up or concave down? Okay, so when you look at a parabola, remember, I'm just writing down a random parabola here. Okay, random equation of a parabola. Maybe it's worth reviewing real fast. You know it's quadratic because there's something squared, right? That's what tells me it's quadratic. And because it's quadratic, I know that the graph will be a parabola because all quadratic functions have a graph that's shaped like a parabola. Okay, so those three things are going together based on the fact that the x is being squared. Okay, so that's the first thing that you might want to remember. The second thing you might want to remember is that standard form is when you have it fully simplified, you've combined like terms and everything, and the exponents go from biggest to smallest. So this is currently in standard form right now. Okay, and when it's in standard form, we identify the three constants using some variables. So in this case, I have a 2 at the front. We call the 2 the value of a. You might remember this all from last semester. And then there's this 8 in front of the x. The number that's in front of x we call b. So the number in front of x squared we call a. The number in front of x we call b. And then there's this number hanging out at the end with no x's at all. That number we call c. Okay, so these are some things that you'll need to remember. They'll be important as we go through this video. Okay, is recognizing what the value of a, b, and c are. And in order to find the value of a, b, and c, you have to first put it in standard form. Okay, so now then, to get to the point of concavity, concavity is the easiest of the three things we're going to talk about. And concavity is just a simple test based on the value of a. Actually, not even on its value, based on the sign of a. So here's our test. If a is positive, then the parabola is concave up. Okay, and you might be able to figure out that the reverse is also true. If a is negative, then the parabola is concave down. Okay, so this is our first test. This is the test for concavity. And simply all you have to do is figure out, is a positive number or a negative number? Okay, again, I think of concave up as being a cup, right? Concave up like a cup. A is positive. If I think about positive people tend to be happy. They smile. Maybe they hang out with friends and they drink soda pop together or something. I don't know. But that's A. A, when it's positive, I'm up like a cup. When A is negative, I'm down like a frown. And people who are negative about everything tend to be upset more often than people who are positive about everything. So negative people tend to frown more often. So this is kind of how I remember it. I just use that little rhyme, up like a cup, down like a frown. Positive people tend to be up. Negative people tend to be down. Okay, and that's kind of how I remember concavity. So let's do a quick example. Let's suppose I have the function. Remember, f of x in function notation, f of x is exactly the same as a y. These are no different. And let's just take this one that I've written here, 2x squared plus 8x minus 9. So decide, if you would, please, whether that is concave up or concave down. If you need to pause the video and think about it, go ahead and pause the video, but decide whether or not you believe that to be concave up or concave down. Okay, so hopefully you've decided that this is concave up. And the way that you know that is you find the x squared. There's my x squared. The number in front of x squared is the value of a. So in this case, a is 2. I recognize that 2 is a positive number. And so according to my rule right here, if a is positive, then the parabola will be concave up. So remember, our goal ultimately is going to be making graphs. And so this is telling me that when I graph it, I know that I'm going to be graphing something that looks like this. That's what this is telling me. I know that the graph is going to be shaped like a cup and not shaped like a frown. Okay, so that's what we've just figured out with concavity. So there's the first test that we need for finding graphs for this particular video. All right, so that takes care of Concavity. Axis of symmetry and the vertex. Remember those two things, as I said a minute ago when we looked at the graph, they go hand in hand, right? The vertex and the axis of symmetry, they always go through the same point. The axis of symmetry goes through the vertex. So if you can find one, you can find the other, okay? Now, think about this for just a second. If the axis of symmetry is a vertical line, remember from our previous unit on vertical and horizontal lines, what do the equation of vertical lines look like? Maybe pause the video for a second and think about that. Once you've got an answer, you can resume the video. What does the equation of a vertical line look like? Well, hopefully you gave that some thought and you remembered that vertical lines always take the form of x equals some number. X equals some number. In this case, my vertical line is 1, 2, 3 units over. So that particular axis of symmetry would be x equals 3. That's what it would look like, okay? Now, the vertex is a point. And if you think for a minute about how we describe points, we always describe points using an ordered pair. So we need an x number and we need a y number. So because the line of symmetry goes through the vertex, the x numbers are going to be the same. So if you can find the x number, it doesn't matter if you want to think of that as being the x number in the vertex or being the x number in the line of symmetry, it's the same either way. And then all you have to do is you have to find the y value. Okay, so that's what we're going to talk about next, is finding the line of symmetry and the x value of the vertex. So the x coordinate of vertex and the line of symmetry's equation. That's what we're going to talk about how to find next, okay? So the first thing to realize, as I said just a second ago, these will have the same number. So whatever number is the x coordinate of the vertex, that number is also going to be the number in the equation for the line of symmetry. And there's a formula for that number. That number can be found using the formula x equals the opposite of b divided by 2 times a. There's our formula. X equals the opposite of b divided by 2 times a. That's the formula for finding the x coordinate of the vertex. That's also the formula for finding the number in the line of symmetry's equation. So let's go back to the equation that we looked at just a minute ago. We had this equation right here, y equals 2x squared plus 8x minus 9. Let's find the line of symmetry for that equation. Y equals 2x squared plus 8x minus 9. Okay. So according to our formula, x equals the opposite of b over 2a. That's our formula. Remember, the way that you find the value of a is you find the x squared, and whatever's in front of x squared, that's the value of a. The way you find the value of b is you find the x. Wherever you find the x, the number that's in front of x, that's the value of b. In this case, they're both positive. Remember, the sign goes with the number, so that plus sign goes with the 8. It's a positive 8. Okay, so I plug those in. The opposite of 8 over 2 times a. Whoops, 2 times a, and a is equal to 2. Okay, just like we've talked about all year long, when I make a substitution, I use parentheses, and then I go through and I figure this out. So the opposite of 8, that's going to be negative 8. 2 times 2, that's going to be 4. And negative 8 divided by 4 is equal to negative 2. So now I know the x number. Now I know the x number. So what that tells me is the equation for the line of symmetry is x equals -2. And the other thing it tells me is that the x coordinate of the vertex is -2. Okay, so those two things are going to be the same. So when we talk about finding the line of symmetry, that equation does it for us. For finding the vertex, that equation gets half of it. We know the x value. We still need to figure out the y value. Okay, but we know the x value now. So how do I find the y value? Well, notice right here, I have a handy dandy equation that tells me what y will be equal to if I know x. And now I know x. So all I'm going to do is I'm going to take this value of x and I'm going to plug it back in to find the value of y. So this is how we get the y coordinate. The y coordinate of the vertex. What we do is once you know the x coordinate, then you plug that number or substitute that number back into the function. Okay. And remember, the function means the equation that's y equals, or if it's written in function notation, it'll say like f of x equals. We're plugging it back into that thing, because remember, f of x and y are the same. That's what we're plugging in. We're not plugging it into this formula. We're not doing that. That formula we're already done with. We're plugging it into this. Okay, so let's find the vertex of the function f of x equals 2x squared plus 8x minus 9, that exact same function. Okay, so we already know from when we used this formula just a second ago that x is equal to -2. We already know that. We just did that right here. We plugged in that formula, I found a and b, plugged it in, x was equal to -2. So we already know that. So all we need is the y coordinate. And to find the y coordinate, you just plug the x coordinate back into the function. So I'm going to take my function right here, and everywhere there's an x, I'm going to plug in -2. So remember from our discussion on function notation, that means I'm finding f of -2. That's what I'm going to do. So every place there's an x, I'm going to replace that x with some parentheses. And inside of those parentheses, I'm going to put the number -2. And then I use the order of operations to simplify this. And this is something that many students have a little bit of trouble with. Remember, when the negative sign is inside the parentheses here, then when you square it, that literally means you're doing a -2 times a -2. The parentheses include the negative sign in there. So it's -2 times -2. A negative times a negative is a positive. 2 times 2 is 4. So a -2 squared becomes a +4. So now I have 2 times +4 plus 8 times -2 minus 9. So that takes care of the first step of the order of operations, the exponent step. The parentheses step, there was nothing to do inside the parentheses, so I could skip the parentheses step. Then I did the exponent step. Now I'm going to do the multiply step. 2 times 4 is 8. 8 times -2 is -16. Minus 9 just drops down. And then last, I'll do my subtraction and addition step. 8 minus 16 is -8. -8 minus 9 is -17. And so that tells me that the vertex is located at So remember, f of x, that's the same as a y. So this is my y value. We already knew the x number right here. We already knew that. So the vertex is, this says is, sorry about my sloppy handwriting. The vertex is my x value, -2, and my y value, -17. And that's my vertex. Okay, so that is the basic things that you need to know for this particular set of homework. You need to be able to find concavity, which means determine if A is positive or negative. You need to be able to find the line of symmetry and the x-coordinate, which means use this formula. And you need to be able to find the full coordinates of the vertex, which means you need to use that formula, and you need to be able to substitute answers back into the function. And that takes care of our learning objectives. We now know how to find concavity of the vertex and the line of symmetry. We know the basic parts. There's these three things, plus there's the x and the y intercepts. And we know how to recognize a quadratic function, and there will be an x squared in a quadratic function. All right, so thanks for watching this video. Have a good one.